program cannot decide for you. So compilation only check the syntax. Logic, okay, can only be confirmed in the simulation output. So if the output is wrong, that is to say that your flow or your logic, okay, in writing the program is wrong. So you think about it, where is the mistake? All right, that one compilation can no way to do it for you. Okay, so for this quarters 2 that we are going to learn here, now beside, okay, compile or understand the VHDL code, this quarters 2, they also have some built-in, a lot of built-in, okay, components already. Those are common components, all has been built into their database already. So beside learning just the code, I also wanted to introduce a little bit of their features lah, whereby we can make use of the written component or written entity in this case here, in case we need it. All right. So the first experiment in this case here, you are going to find that, okay, we are actually introducing how you start off with using quarters 2, then making use of the existing component. Okay, now only I start to record. Okay, this is presenting already. Okay, as I said just now, okay, I go to open up my quarters 2, okay, version 13. So I will see this screen here. Okay, so of course, okay, if you are new to this quarters 2, you create a new project. Okay, you start off with create a new project. So when you start off with creating this new project, okay, you need to do some settings. So these are the settings that you need to do. All right, so we'll go into it one by one. Of course, okay, if you are familiar already, you can say don't show me this introduction again. But I never delete this one because every time I need this one to explain to students. Okay, so once I got this one here, I start to fill in whatever I need to fill in. Okay, automatically you are going to find that this quarters 2, okay, they have this path here for me. Okay, in the C drive, Altera, my versions for this quarters 2 is version 13, 13.0. So follow the lab manual. Okay, I add in the path further. This one here. Okay, so backslash. I create one path called digital. This one here is a Sukahati. If you don't like this path here, you change it on your own. All right, I create this path here, digital lab. Okay, and I put it under lab 1A. Now, I put a space here, lab 1A. If you didn't put a space here, that means that it's slightly different. Provided, okay, if you can remember, no problems. Okay, no problems. So it's lab 1A here. Then this is where my working directory for this project. Okay, project name for this one here, I am going to call it as lab 1A. Okay, project name, I call lab 1A. Then you find that, okay, file name, they come up by themselves. If you don't like it, you can change it. But for this case here, I'm going to leave it, okay, as lab 1A. Okay, so with this, okay, I finish, okay, setting for this first part here. Proceed to next. So in my case here, because I always use this path here, okay, to explain to students. Of course, okay, I already have this file with me. So they are asking me, okay, I want to use back this same path here. Then in your case may not be the same as mine. So I open the project in this quarters 2. They say already exists. Do I want to open? In my case, yes. So in your case, I think it's generate a new one. All right, so I put OK. So you are going to find that, okay, I already have my this lab 1A because I open, Okay, in your case also this one, but my lab 1A, I already have this. Your one is you are going to start to build it. So I will show you how am I going to build this one here. Okay, so well, I know, okay, I'm going a bit too fast already. So next, okay, well, I off this one. Quickly, I go and do this again. Because if with that one, okay, I can't show, okay, so the path, okay, that I am going to generate, okay, I just make it slightly different, so that I can show you the steps. Just I put it as a try, okay. So this one also try, but your one, okay, please follow what I'm showing you just now. So I put in this try here. They say don't have, in your case just now, do not exist. Do you want to create this one? Yes. Then the file name, okay, file name in this case here, just now, I'm using it as a try, right? Try. And you are going to find that, okay, of course, well, I think I made a little bit. So please, okay, key this one as a lab 1A, lab 1A, dot BDF, BDF. BDF stand for board diagram file. Okay, so this is the file that I want. All right, so you can see from here the tab, under the tab here, is about diagram, okay, or schematic file. Like I say, okay, besides, okay, teaching you VHDL, I also wanted to introduce to you the quarters 2 features. They have this block diagram. These components is already in their database. All right, so with this one here, I proceed to the next. Now, this part here, I am going to select the hardware that I am going to download this program. So this program eventually will be downloaded into a hardware. The hardware is in the lab. So this is the reason why I want you to come back, okay? At least, okay, you have a few of the hardware. So the hardware that we are having here, this one, we have to follow here is a Cyclone 2, okay? The hardware here is a Cyclone 2. And Cyclone 2 having a lot of different devices. So the device that we have in the lab here is follow here is a EP2C, okay, EP2C35, somewhere here, 35, okay, EP2C35 F672 672C6. So choose this one. So if you choose the wrong one, never mind. Eventually you can do the correction, but we set it the correct one first. I repeat, EP2C35 F672C6. Somewhere in the middle, okay? You point this one somewhere into the middle. Okay, so with this one here, I select this one. All right. Now, if you don't see all these, it's because, okay, this part here, the target device here, you set it at auto, then they don't come out this. Okay, so you have to specific tells that the device that you want is this one. Okay, so once done, next. So we are going to do these parts here using Modelsim. So under the simulation, can you all find Modelsim Altera? There are a lot of these simulation tools. So the one come together with this freeware here is the Modelsim Altera. So choose this one. So if you didn't see this, that to say, okay, your setting of this Modelsim Altera is somewhere wrong. All right. So at the moment, if you don't find this one, it is okay. You can simply choose any first. But eventually, okay, come to actual simulation that time, there will be a problem. Okay. So choose Modelsim Altera. So that's it for this one here. Then you run the gate level. Okay. Next. Okay, this is the summary of what you have done just now. It's just to double confirm that you are doing the right thing. All right. So now just now I put the path here as try. The top level design entity here is try. So you are going to find that this try is going to give me a problem. So because I labeled the file just now here as lab 1A. So if, okay, if I make a mistake over here, you check and say, hey, how come it's not cyclone 2 instead of cyclone 2, you have a cyclone 4, for example. Then you always can go back, okay, to do whatever corrections that you want to do. Okay, so this one, I type wrongly, isn't it? So never mind, you can change. They are very pandai one, okay? You put here try, automatically they come here with a try. But you can always change it. Okay, so this is done. Then I finish. So you find a lab 1A here. Okay, this lab 1A, wait, can't find my entity lab 1A. This is the under the try. I want to create a new one, ma. Okay, so all right. So with this, okay, I have to start a new file. Okay, because all the while I'm just open up the old one. So with this, okay, I try to go to quarters 2 main menu here, go to the file, new. If you already have, you can just open it. But since we are generating a new one, so new, then they ask me over here, okay, what type of files and so on. So it's a design file. In this case here, we mentioned just now here is a block diagram. So block diagram. Okay. So this workspace comes out. So in this workspace here, I am supposed to later on draw the file. So before I draw it, okay, I will want to save it first, just in case okay, accidentally I off it, then everything gone. So this file here, you save it, give it a name, okay, save as. Then they ask me under my try here, okay, I want to save it as save as this one. Okay, file name lab 1A, save. Then you see here, okay, lab 1A PDF. So this is the file name for the design that I'm going to do. Okay, now I am supposed to draw the schematic. This is the features available in quarters 2. Now this is called the workspace. Okay, in this workspace here, I'm supposed to come up with the component. So over here, anywhere, simply anywhere, you double click. Okay, then the symbol will come up. Okay, now we key in the 74283. Okay, this 74283 is a 4-bit adder. 4-bit adder. Result, okay, of the output here is a 4-bit sum and 1 carry out. Okay, this adder here is a full adder. They have a carry in. And this component, okay, is available in the quarters 2 database already. Maybe just run through here. There are many components available in the quarters 2. These components here are all very standard components. The 74283 here actually follow standard name. This is a IC name for 4-bit full adder. All right, so you find that, okay, you have a lot of components available. All the XOR gate, 3 input, 4 output, everything available. They already write the code for you. All right, so if you need to use it, actually there's no need for you to generate on your own. Just pick whatever you want. Okay, so with this one here, now I okay. So you find that once I okay, when I come back to here, they will follow. All right, then I click, it will stick here. So far, any questions? Let's see, okay, anyone ask anything? Okay, so no, then, all right, maybe I can reduce the size a little bit. Okay, so pull it to this side a bit. All right, so this is the 4-bit full adder. So now follow, and I'm going to add in the input pin and as well as the output pin. So I double click on this workspace again. All right, so the old one will come out, and now you change your name here. You want input, okay, and you want more than one input, so you check on this repeat insert mode. Okay, check on this repeat insert mode, then okay. So you find that, okay, this input will comes in. You need more than one. So this is the reason why, okay, I click on the repeat insert mode. Okay, so if you don't want already, escape. Press escape. Okay, so arrange nicely. All right. Okay, other than this, okay, I also need the output pin. So I double click again. So change this one to output. And you also need more than one output pin here. So again, I check on this repeat insert mode. Okay. Okay. Oh, wrong spelling. O-U-T-B-U-T. Okay. Then okay. So you find that, okay, the output looks something like this. So let me insert all these first. Okay, again, now the one already, escape. Okay, so I get ready with all this. And of course, okay, you try to link them, join them together. Yeah. Okay, easier to do is from here to here. So join one by one. Now, if it's a wrong join already, you see, okay, that one with the cross, okay. Wow, my way of drawing is no good. So this is wrong already. So all I need to erase this one. Okay, let's delete you. Okay, get what the existing first. So this is no good already. Go beyond already. My eye is very blur already. This way easier. Yeah, this way easier. So it's wrong. Anything wrong, okay, you just delete it. Okay. Delete the whole thing first. Because otherwise I can't delete this part. So this is okay already. To me, the most difficult part is this joining. Okay, now maybe I leave it for you to join on your own. Okay, I call back my old file that I already have. So you all please join it properly. So I close this one, don't want to save. No lah. Okay, I got a new one. The old one that I already have. Okay, this is the one. Eventually, okay, you are going to get this. Okay, so you are going to get this. Then, okay, just now I haven't shown you all is the label. Okay, the label here. So you click on it. You click on it. You can just change whatever name that you want. Okay, click on it. Double click on it. So the first one, carry in. Okay, so I type here as a C in. This is a A1 input, B1 input, follow exactly. And for the case of output, same thing. You click on this part, you can change. Okay, so some SO, some S1. So here is a 4 bit. So S3 down to this is a 3 bit, 3 down to 0. All right, and then the carry out. Okay, manage to get all this. Okay, are you ready? Okay, once I label all this ready, okay, I must actually double check that whether any of the wire here, whereby I didn't realize, okay, got short circuited. So of course, this one here is very simple. You can see with your eye, okay, that do this visual inspection. But in more complex circuit, okay, you may find that it is very difficult to do visual inspection. Let the computer to sort of do it for me. So once this one here is done already, we let computer do a little bit of analyzing for us. So what we do is now we go to processing. So we analyze the current file. All right. Then you find out, okay, they give me the result here, successful. Okay, I want to see this word only, successful. Okay, so I already done for my first labs here. So this lab here, this component will not be used again, okay, at later time lah. All right, so lab 1A done. Any questions? Renjen, what do you want me to repeat? Data not available. What are data not available? You show data not available to, okay, compilation. Check and see, okay, whether this is a lab 1A BDF. So check and see whether this is a lab 1A BDF. Check and see, okay, this part here you have is a lab 1A. Anyone got it correct? Anyone got it correct? Anyone got it correct? Got pop out say successful, but the report there write data not available. What data is that? So do you all see this message here? File successful, no error, no warning. At the bottom here, do you see this? One warning maybe is okay. One warning is okay. Quarters 4 analyzing current was successful. 0. One warning is okay. Warning is just ask you to be alert only. Error. What I want is a 0 error. Okay, 0 error. Later on, when you write this VHDL program, sometimes you got 9 warning, 11 warning. It is okay. They just alert you, okay, of a certain parts only. So, important thing is make sure there's no error. Okay. So, now all got it correct. Warning, this one, parallel compilation not licensed. Okay. Well, because we are not paying. Okay, so it is okay. They have this I think they put in more restrictions already. I downloaded this quarters 13 about 2 years ago, when they start off with this online teaching. So yours is a current one, okay? Maybe it's slightly different. They put in more restrictions. Okay, so all got no errors. Yinshen, are you with us? Yinshen? Ming Hang? Okay, no problem. So, okay, so this lab 1A consider done. Okay, consider done. Okay, now, of course, okay, in this case here, make sure you remember to save it. Okay, save it. Okay, in my case here, because I didn't change any of this thing here, so they disable the save for me, because no changes. In your case here, please save. So you save this lab 1A in the path that you create just now. All right. Okay, so we are going to proceed with lab 1B. So in this lab 1B here, I may want to sort of, okay, create a new design project. So I'm going to close this one. Okay to all? All can follow? Anyone with problem, please, okay, let me know. Okay, nobody tell me anything, so all can follow. So I close this one. Yeah, Yinshen? Apa ini? Yinshen, maybe you can talk then faster.
Madam, mine keep downloading but can't open
Say it again. What can't open?
Can't open the software.
Cannot. You cannot go into the software.
Oh, yeah.
Do you install properly or not?
Yeah.
Okay. John was saying that, okay, maybe you need to uninstall and reinstall the software. It takes time. Yinshen is Aaron, isn't it?
Yeah.
Yours is exactly the same as maybe John. You didn't install properly.
I think
so that one take a long time. Okay, so I think I continue first.
Okay.
So with this, okay, I already have, okay, my file here. Okay, so I receive it in. Okay, no problem. So I can off it. Okay, I can just off it. So now I want to generate a new one. I go back to quarters 2 again. So I want to create a new project. So repeat, okay, what we have done just now. So of course, okay, still in the same path, okay, but a little bit slightly different here. Now maybe I want to save it under still, okay, Digital Lab. So all your file here will be under Digital Lab. And this new project here, you may want to call it as Lab 1B. Okay, let 1B, and is also board diagram. Okay, board diagram file, PDF. And the project name, you can call it as Lab 1B as well. Okay, so like I say, okay, they all very pandai one. They come out, okay, Lab 1B for you. If you don't like it, okay, change it. Okay, in some cases, it's compulsory to change because the project name may not be the same as the file name. But in this case here, no problems. Okay, so I go next. I already have this one. Okay, Lab 1B does not exist. Do you want? Okay, I haven't have it. Okay, so file is Lab 1B. Okay, next. So still remember, this one I have to select cyclone 2, and this one is somewhere in. So you see, the default is auto. I must set it to the specific. If it's under auto, I may not be able to find the component. Okay, 35, you see, there's no 35. Okay, no 35. So therefore, can't find, you go to the specific. So it is somewhere in the middle here. Okay, EP2C35F672C6. I double confirm this. Okay, yeah, 35F. Yeah, this is the one. All right, P2C35F6. Okay, correct. C6. Okay, C6 is here. Okay, C6. Next. Okay, simulation. Click it to Modelsim Altera. Then I run the gate level after compilations. Next. Double check this one. Okay, make sure you key in the right one. If it's wrong one, please do corrections. Finish. Okay, this part comes in. And they say, okay, cannot find the design entity, isn't it? So I go and create a new one. Where is the new one? Okay. So again, okay, this file here is a block diagram file. So okay. This thing will come out. Okay, so now we are in this, if you follow your lab manual, it is in page, okay, your page 9. So here say you double click this part. All right, this thing come out. And again, okay, I am going to make use of those file or programs have been generated, and by keying in, okay, some features that I want. So these parts here, I'm going to key in now L, this is L, LPM underscore add subtract. So these components here can do addition as well as subtraction. So the moment I key in this, you see, these components appear. Okay, this component appear. So I just take OK, then they will come to these parts here. Okay, inside this particular components, these components here, what are language that I want it to be written? VHDL, because this is the one that we learned. Okay, we check that this is VHDL, and also we try to check that this is LPM underscore add underscore sub 0, first component. Okay, sub 0, and confirm this is correct. Then next. Okay, I need to do some setting. Okay, I need to tell this device here how many input pin, how many output pin. I decide. Okay, I decide. So quarters 2 having this type of flexibility lah. All right, then you can turn to your page 10 now in your lab manual. So you find that, okay, they ask you what is the width, how wide should the data A? Data A is the input. Okay, input pin. Okay, data A, and this is a bus. Okay, how many bits, okay, you want it to be for the data A? So default here is 8. 8 is the maximum in this case. So but then I don't need so much, I need only 4, so I change it to 4. Okay, what type of features you want this one to do? You can do addition, you can do subtraction, or both. In my case, I just want this one here to perform as an adder, so addition only. All right, then next. Okay, so after this, okay, you find that they will ask you, is the data A or data B input bus value a constant? That means that are you going to put in a fixed value for this one? Answer is no. I want to input different value for A and B lah. No, both value going to change. Okay, do this setting. And what type of features you want to put in here, whether it's a signed number or unsigned number. So this addition is an addition here. We choose unsigned. Okay, unsigned means that the MSB bit is a number, not representing a label. So with this, I next again. Okay, I am going to have a carry input. Okay, I'm going to generate a carry input. The moment I click this one, you see the carry in comes in. Okay, comes in. And the output here, beside the sum also, I want to have a carry out. So this is the sum output. I want a carry out output. Okay, I do the setting. Then quarters 2 responsible for creating the program for me. Okay, so next. So after this, do you want to pipeline the feature? Okay, do you want to pipeline the feature? In this case here, not necessarily. All right, not necessarily. 11. Okay, not necessary. So I just go to the next. This one I think I didn't include in the lab manual there. Okay, not necessary. So next. Oh, sorry. So over here, I can sort of, okay, click finish already. Because subsequently, okay, all not necessary anymore. So don't waste time. So I finish and straight away jump into this parts here. Make sure this is checked. Okay, LPM sub 1 is a component, VHDL. We are doing VHDL component, okay, declaration file. Okay, finish again. Okay, so do you want to pass this one to this Altera and so on? Okay, actually up to you lah. Okay, but in this case here, I just put it as a yes. Okay, so this is the one that I generate as what you see just now. And same thing, I'm going to put in the input. Double click on this area here. I want it the input, okay, and I want more than one. Okay, let me. Yeah, the reason why I have a little bit of problem is because it's too long already. Okay, so I need 2. So 3. Okay, so escape. So this one here, delete first. Okay, so maybe I label this one here first. Now, these are A. I am going to choose this one here as a A. So you type in the A, whether capital letter, small letter, not important. Then you put in a square bracket. Okay, square bracket. Okay, square bracket. And 4-bit, right? So 3 down 2, you put dot dot in the drawing, dot dot 0, close the square bracket. Okay, so this is my A. Okay, my A. So shift this one a bit. Okay, A bring to this side. All right, and you find that, okay, this pin here is a thin one. This is a thick one. Thick here indicate that this is a vector, more than 1 bit. So this time must pull it from this side to here. Yeah. Okay, so you find that this is a thick line. Okay, next, see this one here? I am going to, now, when you click, you can either change it over there, or if they come out with this one, no problem. I just key in, carry in. Carry in is here. Now, see the difference here? Your carry in, okay? Carry in because it's 1 bit, so the line here is a thin one. This is a thick one because this is a vector. All right, vector. So input B also vector. So if it's vector, you want to do the connection that time. Okay? If you were to put it from here, sometimes you will find a little bit of problem. Okay? You see, okay, it's a thin line. So you don't put it from here. Okay? This is wrong, huh? So because you have to put it from the thick one. Okay, so connect it this way. So you see the thick line. All right, and change the name here to B square bracket, open the square bracket. So also 4 pin, right? 4 bit, right? So 3 dot dot 0, close the bracket. Okay, so done for my inputs here. Now go and get your output. Right, wrong spelling again. UTBUT. Okay, and I need more than one. Okay. Okay, quickly I change the name here. This one here is sum. So sum also 4 bit. So 3 dot dot 0. And this one here is a carry out. Carry out is a single bit. Okay, so single bit, whether you pull from which direction, no problem. Okay, but for the case of sum, be careful. You need is a vector. So you pull it this way. Okay, so I got this part here done. And of course, okay, this one here must make sure correct, because later on, okay, when I try to combine or build the structural entity that time, I need this one again. Okay, so confirm that this is correct by going to the processing. Okay, and I try to analyze my current file. You see, they disable me. Why? Because I didn't save it. They disable, I didn't save, right? Anything you never save, okay, you are not going to notice here an asterisk. Okay, an asterisk. So to get rid of this part, go to the file, you save it. Okay, save the file. Okay, what is the name that you want it to be? Okay, because I reset this one here, so I just put it in as a save. All right, so you find that the asterisk here gone. Now this is a save file. So processing, now I can analyze the current file. And I hope no error. Okay, successful. No error. Okay. Then if you want to see back, okay, you can come back, click this one, done. So my lab 1B also done. Okay, so this lab 1 and 1 and 2 here, 1A and 1B here are introducing you to the features available in quarters 2. And we can actually later on, okay, draw our structural model or write our structural model based on existing file available in the quarters 2 as well. Okay, so next, now this is done already. Now go to lab 2. Lab 2 is going to do VHDL already. Okay, so I close this one. Okay, call back because I wanted to create new project. Okay, going to create new project. And over here, you see I in my lab manual here, I skip those steps I expect you to know already. But over here, I repeat this again. So I need to put everything, try to put everything in the same folder. Digital lab. And I backslash. So this parts here, I'm going to call it as lab 2 with a a space, follow with a space. Then the project name here, okay, is a lab 2. So lab 2, so space. Okay, file name cannot be lab 2 anymore because this entity, okay, I give it a name called bin BCD, binary to BCD. Still remember what is BCD or not? Okay, I call it bin BCD, binary to BCD. Okay, and then and the file that I want to play around with now is the VHDL file. VHDL file, the extension is a VHD. Okay, extension is a VHD. Hey, where's my dot? Okay, dot. Okay, what's wrong? Okay, so later on, okay, I must tell that this is a VHD file. So bin BCD first. They don't allow me to press the dot. So next. They told me that it's already there. All right, because I already do it many times. Okay, now after getting this, okay, do the setting. Now I purposely, okay, okay, do something different from this part here. So BCD, okay, bin to BCD, okay. So next, so that I don't have this file. Project already active to you, 1, 2, okay. Now it's nothing wrong. It's just that I want to show you some of the steps. So I close this one first. I don't want this. Sorry, because if I directly use that one, you may not be able to see. Digital Lab. Lab 2. This is a bin underscore 2 BCD. Okay, I purposely change it to different name. So I next. Okay, so if this is the case, I think this is a path, okay, problem. Lab 2. Right, okay. All right, then I next. So they will say it's a new directory. In your case, you are going to see this. Okay, yes. Okay, so under the file name here, you key in the bin BCD. Okay, bin BCD. In my case here, just now I put in is a bin to BCD, right? Okay, just now I put this one. So you follow bin BCD. And this file name here, now you want is the VHD file. So .vhd, and you put in the word. Okay, click this add. All right, so under the tabs here, they will tell you that this is a VHDL file. The file name or the entity name for this one here is a bin to BCD. All right, with this one here, I next. Then do all the setting as the standard one. All right, and choose the specific. $35. And you C6, this is the one. After several times, you will be able to remember. All right, next. And simulation, okay, go for Modelsim, run. Okay, next. Just double check. So I assume this is correct. I finish. And now, okay, you are going to find that when I click it into this, they will still tell me that the file is not there. So I go to the file new. because I don't have this file yet. And over here, because now I'm doing VHDL. Okay, so make sure you choose VHDL file. Okay, VHDL file. Okay. Okay, then you start to type. Okay, the VHDL programs that I'm having or I supply to you all. Okay, of course, okay, no, you can be pandai, you just cut and paste, but that is not the right way. Okay, once you cut and paste here, that means that you didn't learn the syntax. Okay, but in my case here, I'm going to cut and paste. My typing is hopeless. Okay, so I'm going to cut and paste or copy and paste in this case here. Okay, this is the one. Now you see, okay, we start off the VHDL with this library IEEE. Okay, Control C, Control V. So I inserted this, but since okay, I already changed my name to bin to BCD. I remember I must change this one. Otherwise, when come to compilation, that time I have problem. Okay, so the name of this entity must be the same as the name of the file. BCD. Okay, so this one here, Control C, I change here, Control V, Control V. Okay, to suit this part. Okay, it's just to suit, okay, this name here. In your case, follow exactly. All right, so you find that, okay, they come up with some colors for you, okay, to indicate that some other reserved word. Blue color one is the reserved word. All right, so if you key in wrongly, okay, you find that they won't change to the blue color, or this type of parts here will not be changed to a red color, and so on. So these programs here is trying to convert binary number to BCD number by using some very simple programs to do the part. But it is not a good program in the sense that if my binary number, okay, is more than 31. So you find that, okay, my integer range, I only, okay, take it, okay, range from 0 to 31. Okay, I add these two together. All right, okay, I have a BCD1 and BCD2. I then okay have the total binary number is ranging from 0 to 31 only. Therefore, it's a very short program. But like I say, okay, it is not good if this one here getting the number is getting larger. In the assignment, I give a larger number. So you are going to find that this is not suitable to be used. This one here is just trying to introduce to you the concept of VHDL only. So under these programs also just take notes a little bit. This is my entity. Okay, entity, the declaration part. I got one input, two input, one input in and another one input is the clock for this one here. And two outputs. And these outputs here range from 0 to 15. Actually tells the system, okay, reserve 4 bit for me. 0 to 15, actually 4 bit, another 4 bit. Okay, input bin is 5 bits. System will do the reserving of the bits for you. Clock, of course, understood 1 bit only. So this is the interfacing part. And my programs here all responds to the clock. I label it as CLKC. It's a clock. Okay. In this clock here, once okay, I find the rising edge, then they will start to do this one time. All right. So try to understand this program. It's in high level, not that difficult to understand. Then every time clock comes, I have to do this one time. All right. So another clock comes, repeat the same thing again and again. All right. then this is my simple binary to BCD codes. Okay, once we got this part here, of course, okay, for us to be able to compile and check whether any error comes out, I must save this file first. Save. Okay, and I save this file here, cannot be saved in this drive lah, but the file name here must be bin to BCD. So I save. Check here. All right. So once okay, I save already, and now I go to processing. I start compilation, and I hope to see no error also. Okay, got warning, no problems. Now, as long as you don't see anything red here, that means that it is correct, you know. So everything okay, green color, very safe. Okay, green color. So successful. Okay, then they lead me to do the simulation Modelsim. Can do Modelsim already. Okay, and in the Modelsim here, it is quite a long process whereby I need to key in the waveform. Okay, I need to key in the waveform. Okay, so this is part 3A already. Part 3A, key in the waveform accordingly. So to simulate this one, okay, you go to the tools. Actually, it is already here already. So follow the lab manual, go to the tools, go to options. Because it's already here already, so I can't show you the tools and options, all these things here. All right, because I already linked everything. So this part here, okay, quite a tedious process. So I hope, okay, you all can finish this whole thing by today. So I think my recording, I will stop here. So if really cannot, okay, I will proceed afterwards. Cannot stop. So let me stop recording. Okay, class. Okay, for those, Adin, can you share your screen here while you say this one here unsuccessful? This one here is 9:14 baru saja. So I stop presenting. That's why I say, okay, warning is okay as long as no error. Ren Jen, your one with error or not? So can you all share me the your screen, okay, so that I can see, okay, what are the errors that you are having, and let me just figure out what is the problem. So Ren Jen is sharing, so can enlarge a little bit Can you go to the bin BCD, the .bht? Don't want to see the report. See the program first. You also cut and paste Are you also cut and paste, okay, my program?
Yes.
Do you save it, okay, in the right path? Okay, name, is it correct? Bin BCD. That one is here. Also bin BCD. Check the name. Is
Yeah,
it
all correct.
all correct?
How
come Wait. Is it the program? Anyone got it correct? Anyone got it correct? The new, okay, quarters 13. Anyone got it correct? Maybe for time being, okay, just copy and paste into it. Okay, maybe I also should ask, okay, what are the errors that they show you? Can you all read it to me? What error do they show you? At the bottom there. Don't just say unsuccessful. Okay, what error do they, what is the error that they show you? Cannot read. I cannot read, too small for me. Okay, let me read. Can't launch the Modelsim. Modelsim Altera never set properly. The path to the locations of the executable for the Modelsim Altera software was not specified or executable were not found. Okay, it's the Modelsim part. So the Modelsim part. So can y'all go to lab 3A? We solve this problem first. Okay, lab 3A. Let me, okay, Ren Jen, now I share my screen. So we do this one, see whether we can solve the problems or not. Lab 3A. Okay, I need this one. Okay, now this part here, because you say you choose the Modelsim Altera, so you must make sure that the Modelsim Altera is inside this path here. Okay, it cannot be Sukahati anywhere you want to set this. Must be in this path. Okay, so what do I do? Okay, how to confirm this? I go to, okay, from quarters 2 main menu, choose options. So I'm going to sort of close this one. Okay, because this part here I cannot go to the Modelsim, this one. Okay, now come to here, check the tools option. All right, so with this part here, you check EDA2 option and check whether it is here or not. If it's not here, you go to this part, try to find it and link it and make sure, okay, it is of this form. Okay, make sure, okay, the path is of this form. Must be like that. All right, you can go higher up. Okay, I got a lot of this file, okay, very kacau one, okay. After my retirement, I delete all. Okay, so you can go to see there is this Modelsim ASE. All right, so Modelsim ASE, then Win 32. Okay, click on this. Then select the folder. Okay, so I mean, if it's not there, so you go to this part to look for it. So you select the folder, make sure this is correct. Am I make myself clear? Anyone trying? Okay, anyone trying? Then Song Jian, now is it the comparison successful? Forget about the warning. I only want to see no error, 0 error. Anyone manage to get it? Please let me know. Where is the path? Must go and find from if it's not here, come to this part here, the dot 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 here, go and look for it. Of course, it's go up. Now follow this one here is under the 13, okay, 0.0 SP. So you see, okay, 13.0 SP1. So check this part first. I follow this one, Altera 13.0 service pack 1. Then under this path here, go and look for your Modelsim ASE. Now this is the one. Okay, click it. Okay, of course, go inside. After that, go and look for Win32 ALO, which is here. Click on it. Actually, you select this folder. Okay, you select this folder of the this one. So this is the correct path, okay? So in my case, a reset, so I don't want to kacau this part. Okay, so I don't need this one anymore. Another program come out after compilation. What is the program? So maybe Adin, you can share your screen here. I click. Yeah, Modelsim Altera. Yeah, Modelsim Altera should come out. Actually, it is going to lead you to the Lab 3A already. Okay. So do you all see the full compilation? Full compilation successful? So if you can see the Modelsim Altera, it means that, okay, your linking is correct already. Your path is correct already. The rest, are you all okay? So now 0 error, 4 warning. Okay, very good. No error. We want no error. My one got 11 warning. Your one only 4. Right, different versions. Okay, they come up with different types of message. But important thing here is that we are going to see here is a 0 error. The rest, are you all okay? Oh, Calvin, you are very quiet. Brian? Brian, okay. Calvin? Kibun? Dian? Okay, get this part ready first. Okay, can you all proceed? We try to finish, okay, our lab 3A. Okay, well, are y'all okay? The rest, okay, those who are very quiet one, are y'all all right? Oh, it's really slow. Mm. Okay, maybe I can share the screen again and my entire screen again. Okay, so I consider, okay, I already compile this one. Okay, I already compile this one and I wanted to do a simulation. Okay, so maybe this part I record again. Start. Okay, so I compile successfully. Okay, I compile successfully already and I wanted to do simulation. So this is here. Okay, so follow what in the lab manual here. I already link the Modelsim to these tools options that I want to do go for the EDA operations. Okay, now this is what we call it as quarters 2 main menu. I go to the tools again. I try to run simulation tools. Okay, so they will ask me what type of simulation tools that I want to use. I most probably choose the gate level simulation. Okay, so you'll find, okay, once I choose this one here, these things here comes out. Okay, so okay, I just run. Modelsim comes out. And over here, I need to generate my waveform pattern. Okay, I need to generate my waveform pattern for the waveform pattern to test my bin to BCD. Okay, so you find that, okay, over here, I need to go to the simulate. Okay, simulate. With the simulate, okay, I am going to start simulation. Then they will ask me, okay, which is the design unit that you want to do the simulation? I must remember this. Now I'm using the bin to BCD. In your case, is bin BCD only. Okay, and when I type in this one here, no need to put .bht. You put .bht, then they cannot. Okay, they cannot compile. They only need the file name. Okay, then press OK. And you are going to find that you have my input and output appear here. Okay, for this bin BCD, the input and output pins appear here. Now, if you don't have these parts here, you may need to sort of, okay, find it out on your own under, if you don't see this, then you have to go to the, Okay, if you don't see this, okay, you have to sort of, okay, find it from, you are not mistaken, okay, this tools, view, yeah, under the view, okay, the wave, okay, select the wave, if you don't see it, okay, select the object and with, okay, object is this one, waveform, later on shown here, okay, under the view, okay, what are the things that you want to view, meaning object and wave, okay. So this is something that is correct. Now what I'm going to do is I'm going to drag the input and output pin from object wave to the object window to the wave window. So I know that my input in this case here is bin. So I drag. So look at here, the sign here, input going in, input. Then I also have another input that is the clock. Suka hati, okay, which one you want to come first, okay? But normally we try to arrange, okay, all input first. So if you want to rearrange location, no problem. So clock is on top, bin is at the bottom now. Then I have my bin 1, BCD 1, BCD 2 as the output. I drag it to this side first, okay? Then after that, in this wave window here, you click on the input pin. Let's say the clock. Okay. Then here they will ask me, how am I going to generate my clock signal here? Okay, sorry, I made a mistake. So I right click here first because this is a clock. So I am going to choose this one as a clock. Easier, okay, this way. Right click, clock. Then you find that, okay, this one will come out and ask me, okay, what is the duty cycle that you want for the clock? Usually it's 50%. Then what is the period that you want for the clock? So in this case, actually, what we can do is follow. You can change this one, the period you can change. This part no need to change already because it's the path that you want. All right, offset correct already. Period up to you. You want to change or not? If not, then just leave it as 100. You want to start the device, okay, start from high, then go to low. Okay, high, go to low. And you want to start the first signal here as rising edge or falling edge. Signal going up first or signal going down first as the first pin. Suka hati, you decide. Okay, then once you set this one here, I don't want to do much on this part. I just leave it as in this form. Okay, so we choose the define here. You can change the length. All right, like I say, okay, suka hati, you change this part here, the time, okay, the time period. Then I okay. So here you find that, okay, this part here, once I click okay, they come up with this for me. False. Okay, this is the how do I say, the code that they use to write. Sometimes, okay, those especially those who are expert already, okay, they don't want to go through this type of a slow process. They immediately, okay, just dump this line into it. Then system will know that, okay, you are setting your clock signal. Okay, your input clock signal as in this form, 10. Okay, the timing or the how do I say, the period is 100 picosecond. So high and low, each one 50 lah. All right. Then this is a code. Okay, if you check my this lab manual, you will find that, okay, I show you some, not all, not many. Okay, I show you some of the commonly used coding. Okay, first one set. Then subsequently, okay, I go to the bin. Okay, I first, okay, I must tell the system here what is the ready, means the base. Okay, the base that I'm using. Okay, whether it's in decimal, base of 10, binary, octa, sign, unsigned, and so on. So you choose suka hati. So easier for us to, C will be in decimal. So I choose here as decimal. You can change, no problems. Okay, so I select this one. Okay, that I know that now this is in decimal. Then I right click again. Okay. Okay, right click again. Choose the false. Okay. So after this, okay, you find that okay, I know that this binary number is 5 bits. Okay. So Sukahati, I will key in the value. And I decided just now that I use decimal, isn't it? So if it's decimal, you can key in 13. If you choose the binary, you key in 01101. You can change this number. Like I say, okay, this is for you to do your simulation input. I input a value of decimal 13. All right, I input this value. Then I tell the system that, okay, my first value that I'm going to set here is 13 up to, okay, up to 200 picosecond. Then haven't finished yet. I didn't cancel. So leave it blank. Okay. Okay. Then sort of like you are going to repeat this. Okay. You are going to repeat this. So right click again and force again. And now, okay, still the same thing. Now you put in a different value. In this case here, let's say 21. Follow the page 18, 21. And the delay here, just now 200, right? Now I put 400. 400. All right. Also still this part here blank. Then I okay. So you see here, whatever I insert just now, okay, appear here. Okay, one more. False. Okay, and now the value that I want here to be is 15. Okay, and I make it okay 600. And I say, okay, cancel 800. So I'm going to stop at 800. Okay, so you find here, it appears here. Okay, so I have done all this setting here. This one here is because I choose it as value number. And with this, okay, sometimes, okay, you don't want to keep on doing this process very slow, isn't it? So what you can do is you copy this one. Okay, Control C, you put into a notepad. Okay, I already have my notepad. Okay, put into the notepad. Just in case, okay, you need it again, then you can just dump it in. It make your life easier. Okay, where is my notepad? Okay, so how come they cannot show me? Okay, I just keep it here. All right, I just keep it here. Okay, then okay, once this thing here is all done, I am going to okay run this value that I put in, okay, by going to simulate. Okay, start my simulation by running all, run all. So can you all see it? This is the waveform that I put in just now, the clock. Okay, and this is the binary input that I put in. Now you say that, okay, this part here, if you want to change it now, the radius to binary, no problems. Immediately they change to binary for you. And very messy, isn't it? So I change it back to decimal. So this is the input, okay, in decimal. And I am trying to change this one into two different values. Okay. Oh, I make a mistake. I put bin. I take both, okay, BCD one. That's why I see all the same value. Okay, so this is a mistake here. So I'm going to stop this. So I break. Okay. Luckily I saved this now. Start simulation. Wait, so bin to BCD. BCD. Okay. Okay, so this thing comes out. My object, view. Okay, wave is here. So I repeat this. Clock. Just now my mistake is okay. I took both the same one. Okay, so now I try to have this one okay corrected. And because okay, I don't want to go through the same process of inserting the part. So remember just now I copy down all the value that I set. Now I use back. Okay, so this is the one that I'm having. So I enter. So with this one, I simulate. I start simulation. This is the bin underscore 2 underscore BCD. Apa ini? Bin 2 underscore BCD. Okay. We got it. What is going wrong? Did I do the right thing? Sorry, okay. I think I repeat this one too many times already. Okay. Control V. Okay, this Control V here, and now I wanted to run. Okay, I wanted to run. I go to simulate run all, simulate run. Okay, run all. So you find that okay, sometimes you don't see anything here, doesn't matter. This one you pull it back. Okay. Enter. I simulate again. Run all. Okay. Do I get any waveform? Do I miss out any parts here? Freeze this one. No. It's here. Okay. So because we only simulate very few signal lah. That's why you find that they will show you towards the end but you pull back this. All right. So you are going to find that my list programs here. Okay, I input a decimal number of 13. They are going to break this 13 for me into 1, 3. This one indicate 10. This one is a single digit. If I put 21, you will see 2, 1. Of course, you can put in more value. So here I put 15. They give me 1, 5. All right. And these things here happens at rising age. Okay, at rising age, because I say, under the rising age, I want this one here to operate. Okay, it based on your programs. So this is a waveform that you are going to see. Now, I think when you are doing your simulation that time, you are going to find that the background is a black color. Okay, the background is black color. So you change your background color, especially when come to report. I don't want to see. Okay, the background is black color. So you go to tools. Okay, follow in page 16. I teach you how to change the background color to white color, and also put in this label into it. All right. So if you don't see this part here, okay, you put in this label. All right, so this part here is to confirm that this program here now managed to change binary number, separate them into BCD number. Okay, so from 13 it's very easy to see, but if you put it into a binary number, okay, change already here to binary, then you got to spend a little bit of time to analyze. Okay, you can enlarge this one. Okay, you can enlarge this one if you want to. Okay. Wow, I see all this 0 and 1, I got headache already. Okay, so change back to decimal. Okay, so this is a 3B. So I hope today we can stop at least up to here. So I stop recording. So class, remember to save your simulation pattern in the notepad or words here, especially when you are doing this assignment at time, because you may need to keep on repeating, confirm that it is correct. Meanwhile, if you think that, oh, this is no good, then you can change here straight away. So you think that the timing for 200 too long, you want to change it to 100, just change it and then add more values onto it. So like in this case here, let's say I add more values. So let's say I add more value. What I can do is here, Control V. So this one I make it, let's say 1000. This one here I don't want 15. Of course, I don't want to use the same thing. I use a 08, for example. Okay, or 8. Okay, or 8. 100 cancel 800. Modify to suit the conditions. 800. Okay, let's say this is the one that I want to test now. So I add in a number 8. Okay, I copy this. Back to here. I try to do a simulation, or straight away from here, I already have this. And now, now from here, I haven't stopped it because just now I was running and I need to stop it. So here you see, I'm still running. So I try to break it. So break, it will give you this. Then you come back to wave. Okay. Come back to wave. So pull this one to the front part. Signal is still there, but I want to change it. So I come to here. I insert the new pattern, which I modified just now. And I go to the simulate, run all. Okay, then you find that 13, 21, 15. I key in 0. Oh, I didn't copy the right thing. Never mind. See, I still insert the wrong one. I break. Okay, then come back to this. Correct one. Control V. Let's check. 200. This one 100. Okay. I break already. I run all. So pull this one to the front. My problem with this one here is the 08. How come I don't see the 08 here? Okay, now class, you can try on your own now. Okay, so is it because this one here, I want to change this label, okay, to 9 or 09? Is it they cannot clear? Maybe I need to quit this one, okay, before, okay, I continue to, okay, let's see this, if this one cannot, that means that I have to quit this window again, and I go in again, so I simulate, run all. Yeah, I think I need to quit this window because they always use back, remember the old signal. So I am going to break this one. Okay, then stop this. Okay, are you sure you want to quit? Yes. And from here, I go to the processing, run simulation 2, gate level, run. So simulate. How come they never ask me for design? They never ask me for design. Okay, this one here is a pin to ECD. Okay. Okay, the rest are okay already. Okay, no problem. Okay, now I go to simulate. Okay. Okay, let's go for 31 or 30. Then I run all. Now this is working properly. All right. Now I change, okay, my this part here, okay, to 30. So they break it for me, okay, 30. Maximum you can put in the number here will be 31 because you only allocate 5 bits. Okay, 5 bit, the maximum number is 31. I say Sukahati, okay, you can change your setting, okay, accordingly. So you can do more simulation, especially when come to your assignment. You have to convince me that, okay, your program is correct. Okay, so today we will stop up to here. Mm. Class, any question? Can you get this waveform? If you all want the pattern, okay, I can put it over here. You all just copy and paste. Okay, this is the one. You can change, okay, whatever the number here, Sukahati. Okay, and you can add in more if you want to. Okay, the next this lab practical here, you will sort of, okay, type on your own, do on your own. I will not be coaching you all, okay, like what I'm doing today. Okay, for next practical, we will try to finish until before the downloading. Okay, we are downloading, we have to do it in the lab. Okay, on week 5. Okay, any question before we end for this lab practical? Next week, the other Thursday call UC declare holiday. So we will do. I will see you again on week 4. Yeah, whole week 3. No class for you. Monday I on leave. Like I say, okay. Usually, you know lah, got to cook and so on. So the day before is very busy. Yeah. Adin, join us lor. You also holiday, yeah. So in Malaysia, we have so many holidays, too many already until our productivity very low. But you go and do some homework. Mm. Holiday good. I know holiday good, but if you are the tauke, then it is no good. Now assignment is 2 person in a group. Okay, assignment is 2 person in a group, but your this class here is a odd number. So only one group can have 3 person. Only one group can have 3 person. So assignment is all okay. Making use of VHDL lah. Write code, cannot draw. Must write, because in the exam is write. So got to train you, okay, for the exam. Assignment after, okay, I show you all the downloading part. Everybody, okay, know how to do the downloading part already. Then you can start off with your assignment. Assignment what's in theory, but of course, okay, lab will be still on. You can do during your lab hours. Actually, the last 2 weeks. All right. But if you finish your downloading earlier, the moment you finish already, you can start off with your assignment, which is on the 3rd lab practical. You form your own group, you discuss. Of course, when you write that time, okay, VHDL that time, you may face some problems. Okay, compile that time, a lot of errors come out. Go and sort out the error one by one. And make sure the logic is correct. Okay, so today we end the class here. Now, are we going to break for 1 hour or half an hour, things like that? Because we still have 1 hour lecture. Many of you haven't taken breakfast, is it? Hey, please answer lah. How many have you haven't take breakfast? Adin sudah makan. The rest? Who belum makan? You makan roti while you are listening lah. Okay, so maybe half an hour break lah for those who haven't makan. Okay, go and makan. So we start at 10:30, 1 hour class. Okay.